Okay, so today we are just going to, I'm not going to use the PowerPoints. It's basically a bunch of examples that we'll go over together. But today we're going to learn how to take a formula and name it. So it's pretty easy. We've already done this every day, this whole unit, except it gets kind of tricky when we get down to the multiple possible charges, which you'll see when we get down there. So I'm just going to have the polyatomic ion sheet up on the screen instead of the PowerPoint so that we can just refer to it. The PowerPoint is kind of useless right now since we're doing these together. So this, we're just naming it. So we always know that the cation is just its name. So we just call this potassium. And this right here, if it's on the periodic table, which it is, it's not a polyatomic ion, it's called bromide. Okay, we replace the ending with IDE. That's it. This one is, these are both on the periodic table, calcium and then iodine. So it'd be calcium iodide. So basically the only thing you're changing is this part right here. That's it. How easy is this unit? I'm sure it's refreshing to you guys. So this right here is just its name, okay? So here is sodium. And here, please guys, don't ask me in the test, Miss, I can't find SO4 on the periodic table. You never will, guys. You gotta find it on the polyatomic. This is polyatomic, more than one, many atoms, ion. So you have to find it on the polyatomic ion list, okay? I will just say do the best you can, because if it's by test time and you don't know that this is not on the periodic table, you did not study prior. SO4, let's find it on the the polyatomic ion sheet. Here it is. It's sulfate, okay? So SO4. So sulfate. There. So sodium sulfate. That's it. That's all you have to do when you name it. Now the last four, these all are, if you've noticed, iron, tin, copper, cobalt. So tin is over here, but I know it has multiple charges. Cobalt, copper, and iron. Jordan, do not give Fastiki any more Cheerios. You're gonna make him sick. Anyways, all of those are have multiple charges. So in this case, we will have to add a Roman numeral. So a good rule is if it is a transition metal, okay, if it's any of these and a little bit further down to the left of the staircase, but not group 1 and 2, you're going to probably have to do a Roman numeral. A juice lid? Go throw it in the trash, Jordan. He could choke and die on that. Anyways, so here we're gonna have to do Roman numerals. Sorry, guys. All right, so iron, that has multiple charges. It's to the left of that staircase. Okay, here's our staircase. It's to the left. Iron is actually right here. So it could have more than one charge. It could be +3, +4. So we have to actually do a little bit of calculating. So this we cannot find on the periodic table. It's a polyatomic ion, so we need to find it. CrO4. So here it is. It's chromate. It has a -2 charge, okay? So it has a -2 charge, this thing does. However, we have 3 of them. So we need to do 2 times 3, which is a -6. So we have 2 irons. So what I do is I find out how much this thing is, what the net charge is. I take this number and divide it. So that means iron has to be a +3 charge. Yes, it'll be a -3, but since it's a cation, it's going to be a plus charge. So iron will be a +3 charge. So the name of it will be, iron. Okay, iron. Roman numeral 3. Chromate. Okay, this is 10, okay? 10 is right here, okay? So it is to the left of that staircase, so it does have multiple charges associated with it. We just have to find out what it is. So there's only one 10 in this molecule. So one 10 in this molecule means that whatever this thing's charge is, 10 will be all of that charge, but in the positive form. So we just need to find, this is not on the periodic table, right? This is a capital C, capital O. So we will have to find it on the polyatomic ion sheet. Capital C, capital O is CO3, so it's carbonate, okay? So CO3 with a -2 charge. So CO3 has a -2 charge. There's 2 of them, so we're going to multiply it by 2 and we'll have a -4 charge. That means 10 must be a +4 charge because this whole molecule has to be neutral. So that would make this 10, 4, what was it? Carbonate. Okay, and now we have Cu3P. So copper again, copper is right here, and it's one of those transition metals. We have that stair step here, and it's to the left of the stair step. So copper is here. It could be multiple charges. So we have phosphorus. So that's actually on the periodic table. Phosphorus has a -3 charge. So we have a -3 charge here, and we have 3 coppers. So we have -3 charge, and we need to divide it by 3. So that makes this a +1 charge. So we still have to put the Roman numeral even if it's a +1 charge. So it would be copper 1 phosphide, okay? And last one, we have cobalt and this thing, which you won't find on the periodic table. Cobalt is going to have multiple charges. It's to the left of that staircase, but not group 1 and 2. So we just need to find out what charge this is. So that's CrO4, which was actually up here, but I'm going to find it again. CrO4 is here. So it has a -2 charge, and there's 3 of them. So altogether, the anion side has a -6 charge. That means the cation side must have a +6 charge. There's 2 of them, okay? So we divide that by 2, and that means the Roman numeral will be 3. So it would be cobalt, Roman numeral 3. What was this thing called? Chromate. That's it. That's how you solve for naming the compounds that have multiple charges, basically from the beginning of transition metals all the way to the staircase. These bottom 4 are how you solve it that way. And then the top 3 are super easy. You just name its first cation, its name, and then the second part, whatever its name is with "ide" at the end. Unless it's a polyatomic ion, which would have its name that it's listed in on the polyatomic ion sheet.